This map shows the current severe weather risk zones stretching from Montana down to Texas and all the way across to New York. Today, over 100 million Americans are living within the path of these fragmented storms. A continuous chain reaction of atmospheric volatility will keep these storms firing across the country for the next 12 to 24 hours. Across these different regions, the environment is currently supporting large hail, severe damaging winds, and isolated tornadoes simultaneously. This widespread activity marks the start of a week-long atmospheric escalation that will see these scattered risks consolidate into more organized threats. To understand how this week evolves, we have to look at the three separate regional engines driving today's weather. On the East Coast, afternoon heating is triggering scattered, popcorn-style thunderstorms, bringing localized downburst winds and small hail to cities like Washington and New York. In Dixie Alley, the threat comes from residual atmospheric spin left over from morning systems, which creates a specific risk for isolated tornadoes across the Tennessee Valley through this evening. Further west, the high plains are experiencing a mechanism called upslope flow. Horizontal winds smash into the Rockies, deflect sharply upward, and bloom into discrete supercell thunderstorms. These intense vertical currents can suspend heavy frozen water droplets for extended periods, resulting in baseball-sized hail targeting high-altitude cities like Denver and Rapid City. While these regional threats are operating independently today, the atmosphere is preparing to pool this energy into a single, highly organized force tomorrow. By Tuesday, the focus moves to the Midwest and the Central Plains as the atmospheric energy begins to pool together. The primary threat transitions into a mesoscale convective system, a massive, organized line of thunderstorms that moves together as a single destructive wall. Forecast models disagree on where this line begins. The HRRR model starts it over Kansas, while the Rufus model points to Colorado and Nebraska. Yet both converge on the same outcome, an 80 to 100 mile per hour wind threat tearing eastward Tuesday evening. This mesoscale convective system acts like an atmospheric bulldozer, sweeping across the plains and clearing out the scattered energy, which significantly alters the weather pattern for the rest of the week. Following that wind event, the severe weather activity will briefly drop off across Wednesday and Thursday. Isolated storms will still develop along the Rockies and the northern plains, but the high-end, widespread danger temporarily subsides. The atmosphere is now entering an active reloading period, hoarding energy for a massive climax over the weekend. Transitioning into the weekend forecast, a massive surge of energy-rich air will flood directly into the northern plains. Meteorologists measure instability in joules per kilogram. A typical severe weather environment sits between 1 and 2,000 joules, but Sunday models project a spike reaching 6,000. Seeing this metric several days out is highly anomalous, pointing to a hyper-favorable environment for storm growth. This instability remains dormant potential energy until an atmospheric trigger arrives to ignite it. The central United States is essentially being transformed into a continental powder keg, waiting for a final spark to provide the lift. That spark arrives on Sunday as a powerful low-pressure system crashes into the northwest and collides with the unstable air mass. The overlapping of strong low-level winds and intense upper-level winds creates extreme wind shear, setting the stage for a major tornado outbreak across the Dakotas. By Monday, the margin for error in the forecast becomes incredibly thin as we track the precise path of this system. This map shows the high-stakes tipping point. If the center of this low-pressure system shifts just 100 miles further east than currently forecasted, it will drag this explosive environment directly over the highly populated Midwest. This week-long escalation shows how rapidly atmospheric conditions can intensify. Residents should monitor the changing models and prepare immediately as this storm train approaches.